Hello everyone, myself Harismita Reddy.S. I'm currently in my third sem of computer science engineering. In this video, I'll be discussing about the applications of logic gates in real life and also a quick introduction to logic gates. Now, the topics that we're going to discuss are introduction to logic gates and types of logic gates, which include AND gate, OR gate, NOT gate, NAND gate, and NOR gate, XOR gate, and XNOR gate. And we're also going to discuss about the applications of all these gates. Introduction to logic gates. The word logic itself gives us an idea that they work on certain kind of logical operations. Logic gates are the integral part of digital mathematics. A logic gate is a device performing an elementary Boolean function, producing a logical 0 or 1 output depending on one or several such logical inputs, implemented with either electronic, optic, mechanical, or even biological devices. Logic gates can be composed into physical models of all conceivable algorithms or computation. Logic gates are the building blocks of digital circuits in which diodes and transistors are used to perform switching functions. By combining thousands or millions of logic gates, it is possible to perform highly complex logic operations. A truth table helps us to show the functions of a logic gate. Now coming to types of gates, we have the first gate, AND gate. An AND gate receives A and B inputs where A and B are bits and produce an output denoted by AB. Here in the diagram you can see the logic diagram of the AND gate and also the truth table for the AND gate. OR gate. The OR gate receives input A and B where A and B are bits and produce output denoted by A plus B. An OR gate is a digital logic gate that produces a high output 1 when any of its inputs are high and a low output 0 when all of its inputs are low. NOT gate. A NOT gate or inverter receives input A where A is a bit and produces output denoted by A asterisk or A bar. A NOT gate is a logic gate that performs logical negation by outputting the opposite of the input bit. NAND gate. NOT AND gate is equal to an AND gate followed by a NOT gate. The outputs of all NAND gates are high if any inputs are low. The symbol is an AND gate with a small circle on the output. The small circle represents inversion. NOR gate. NOT OR gate is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. The NOR gate is shown below in the diagram along with the truth table for the NOR gate. XOR gate. The exclusive OR gate, also known as XOR gate, is a circuit which will give a high output if either but not both of its two inputs are high. An encircled plus sign is used to show the EOR operation. The EOR gate, also known as the XOR gate, is shown in the logic diagram below. XNOR gate. The exclusive NOR gate circuit does the opposite to the EOR gate. It will give a low output if either but not both of its two inputs are high. The symbol is an XOR gate with a small circle on the output. The small circle represents inversion. Here in the diagram you can see the logic diagram of the XOR gate and also the truth table. Now, applications of the logic gates. The applications of logic gates are mainly determined based upon their truth table, that is their mode of operations. The basic logic gates are used in many circuits like a push button lock, light activated burglar alarm, safety thermostat, an automatic watering system. Digital communication cannot happen without logic operations. Daily life application of EOR or NOR gate can be related to ladder switches used in homes or can be found in water level checker circuits. AND gate. Now, applications of AND gate. AND gates are used to combine multiple signals. If all the signals are true, then the output will also be true. If any of the signals are false, then the output will be false. ANDs aren't used as much as NAND gates. NAND gates use less components and have the advantage that they be used as an inverter. AND gate is used in security alarm. OR gate, whenever the occurrence of any one or more than one event is needed to be detected or some actions are to be taken after their occurrence. In all those cases, OR gates can be used. NOT gate. NOT gates are also known as inverter because they invert the output given to them and show the reverse result. Now the CMOS inverters are commonly used to build square wave oscillators which are used for generating clock signals. The advantage of using these is they consume low power and their interfacing is very easy compared to other logic gates. NAND gate. NAND gate device failure alarm system. uh, when all the fans are working, the input to the NAND gate is 111 and the output is 0. If any one of the fans stops working, the output of the NAND gate becomes 1, which activates the alarm. NOR gate. Uh, an application of NOR gate is a washing machine controller. A washing machine has three sensors to check for washing machine lid open, washing tub filled to minimum level, and weight of clothes and the water in the tub. If the machine lid is open or the water in the tub is below certain level or the machine is overloaded, that is the weight of the water and clothes in the tub is above certain limit, the output of the corresponding sensor is set to 1, producing a 0 at the NOR gate output that switches the machine off. Thank you for staying with me till the end, and I hope you guys found the video informative.